Hi guys, welcome back to 3 Inquisitive Kids. In this video, we will be looking at Contest 1 of the recent 2022 to 2023 Division E Math Olympiad problems. So here, there are 5 questions. Usually the first one is the easiest, while the last one is the hardest. Now here's a bit more background about Math Olympiad in case you don't know yet. So Math Olympiad is a contest, it's optional, that is given to grades, I believe, 4 to 6, something like that. So late elementary school and middle school. And all of these questions can be solved using the basic math concepts that you learn in school. All of these questions are solvable. Now, what's different about Math Olympiad is that it's not those, order of operations or find common denominator or fraction problems. No. What's special about Math Olympiad is that it challenges your brain to think flexibly, to think out of the box. And you have to combine a bit of this and a bit of that in order to solve this problem. Now, a lot of the times, schools might have a class or maybe a club that does Math Olympiad. So if you do go to an elementary or middle school, you can ask your teachers if you have any. There is also a Division M for middle school, but here we're looking at Division E. Now, when you're solving this, you're given 30 minutes to complete this contest, and no calculators are permitted. So that's just some things about the Math Olympiad contests. Now let's get straight into these questions. The first one is, what whole number is equal to 222 plus 2022 plus 2202 plus 2220? See how they played with the numbers a little bit? Because this was given in November of 2022. Anyways, let's add. So a lot of the times it's really easy to mess up on this type of problem, even though you know addition, because you might not have the clearest work and you may not be showing your work the best. And that's usually when people get confused with their own math. So here we're going to write it out. 222 plus 2022 plus 2202 plus 2220. Now we're going to add. So in the ones column, we have a 6, a 6, a 6, and a 6. As you can see, each place value adds up to 6. So our final answer would be 6,666. Now, something else about Math Olympiad. If you were actually taking this contest as a competitor and you were going to submit it, on the actual paper, they give you 5 boxes, and that's the answer column. It's very important that you only write the number parts. They don't require a unit or anything like that, and say the answer was 50 centimeters squared, but you wrote in 50 meters squared instead. Let's say that's what happened. You will still get a question wrong for having the wrong unit. So it's best just leaving the unit out. Now, when you're doing normal tests, they probably require you to add the unit, but in Math Olympiad, it's special. You do not need to have the unit. All right, let's do the second question. And I'm going to move my work next to the problem so we can refer back to it later if we need to. At Todd Morton's Donut Shop, many donuts are sold in boxes of 5, 10, and 20. What is the least number of boxes that must be bought to acquire exactly 95 mini donuts? Well, let's first write it in an equation. We don't know exactly how many boxes of what size we're going to buy. So let's say that we buy A boxes of 5, so that would be 5A, plus, so let's say B, so 10B. B represents the number of boxes that have 10 in them, plus 20C. C represents the number of boxes that have 20 donuts inside them. And they sum up to 95 mini donuts exactly. Now we're trying to find a solution to this equation when the sum of A, B, and C is the smallest. So how can we do this? Let's think about this logically. We are trying to get exactly 95 mini donuts. So if we were to get the least number of boxes, the goal that we're trying to aim for is to get as many boxes of 20 as possible. So we were trying to get C to be as much as possible. How many groups of 20 fits into 95? 20, 40, 60, 80. 80 would be what 20C equals, so C would be equal to 4. Now what about the others? If we already have an 80, then 5A plus 10B has to sum up to 15, which means A is equal to 1 and B is equal to 1. This is one of the solutions to this indefinite equation. Now, we actually made a series about indefinite equations in the past, so I will be putting the link to that in the description down below if you would like to learn more about indefinite equations. Now here, this is a concept that maybe not all elementary levels touch up on, writing an equation out like this, but still, you can think of it logically. So starting with 20, counting in 20s until you can't count anymore, and then adding 10 and 5. Now this problem isn't really a mathy problem. I'd say it's more of logic and reasoning, because the key point here is thinking about where to begin. And that point is knowing that you have to begin with counting the number of boxes of 20. And our answer is the least number of boxes. So again, this is not our answer. We have to add up 4 and 1 and 1, which would be 6. Also, when you're answering, you can even just write the unit right here outside, 6 boxes. But this would be the answer that your test corrector sees. Now let's start by listing out all of the common factors between 96 and 120. So let's list out all of the factors of 96 and then check they are a factor of 120 as well. So that would be 1, 96, 2, 48, 3, 32, 4, 24, 6, and 16. And finally, we also have 8 and 12. So these are the factors of 96. Now we can cancel out the ones that are not factors of 120. So we can cross out 96, 48 goes out as well, also 32, and 16. Now we're going to see which of these factors do not share a common factor with 105 other than 1. So 1 would obviously have to go. 3 and 105 all share a factor of 3, so 3 can also be eliminated. 4 and 105 do not share any common factors, so 4 can be eliminated as well. Since 12 and 105 are both multiples of 3, 12 will also have to be eliminated, which leaves us with 2 and 8. Now let's go back to the question. It says, what is the greatest counting number? Which means that 8 would be our answer on this one. Alright, now we're halfway through the contest. 1D. The figure shown was created when 5 rectangles were placed side by side. Each rectangle has a base of 2 centimeters. The heights of the 5 rectangles are 1 centimeters, 2 centimeters, 4 centimeters, 6 centimeters, and 8 centimeters. Compute the perimeter of the entire figure in centimeters. Here I did my best to reconstruct the image that was on the contest. So let's first start by labeling these parameters. The heights are 1, 2, 4, 6, and 8. And their bases are all 2, 2, 2, 2, and 2. Now it's saying to compute the perimeter of the entire figure, which means that we don't need to count these spaces in the middle right here. We need to count these parts, but not this part. So that might be one of the confusing parts, is you don't know whether to count all of the lines or just the perimeter. We're just looking for the perimeter. So we can start by, well, we could just add, right? So we can do 1, and since this has a difference of 1, I'm going to write 1 right here and erase all of these numbers so we understand better. So then here we would have 2, 2, and 2. As you can see, we then have 1 plus 2. Actually, let's first do the width across. So we know that here it's 10. And if we add all of these little sections up, it's also 10. So that would be 20. And then we add these vertical parts. So this would be 1 plus 1 plus 2 plus 2 plus 2. And then we have to add this entire section. 1 plus 1 is 2. 2 plus 2 plus 2 plus 2 is 8. Times that by this entire section right here, which is the same thing, you have 16. So 16 plus 20 is equal to 36. Our final answer would be 36 centimeters. But remember, you only need to write the 36 in the answer box. Now let's move on to our final question. This is often the most complicated and the most difficult to answer. The digits A, B, C, and D are used to perform the 4-digit number ABCD. How many 4-digit numbers have the following 3 properties? 1. The digits A and D are the same. 2. The digit B is less than any of the other digits. And the digit C has a value that is halfway between the digits B and D. For example, 7,357 is such a number. So let's reread this question. There is a 4-digit number A, B, C, and D, and we are trying to find what it could represent. So A, B, C, D, I'm going to write them out as separate place values. A and D are the same, okay? Which means that A cannot and D cannot be equal to 0. Because if A was equal to 0, then it would not be a 4-digit number. 0 cannot be the leading digit in any number. And the digit B needs to be less than any of the other digits. We also know that the digit C is exactly halfway between the digits B and D. The way to solving this problem is to just list everything out. How do we do this? Well, let's start with the smallest options. You can either start with the largest or the smallest, but you need to have an order to keep your thinking clear. Let's first start with A and D. A and D cannot be equal to 0, and it cannot be equal to 1. If it were 1, C would not exist, which means that their minimum number would equal 2. If that were the case, B would have to equal 0 in order for C to have a digit. So then we have the number 2012. Now let's see if A and D were 3. If that were the case, B can equal 1 and C can equal 2. Let's do another one. If A and D each equaled 4, B could equal 0 and C would equal 2. Another option would be if B was equal to 1 and C was equal to 3. Now let's do 5s. A and D is equal to 5. B can be equal to 1, and the reason why I didn't say 0 would be because then C would be equal to 2.5, and that's not a digit. So if B is equal to 1, C would be equal to 3. but B cannot also be equal to 2, but it can be equal to 3, which means C is 4. So we have the number 5,345. Now I'm starting to run out of space, so I'm going to move to this section right here. If A and D were equal to 6 and 6, what would B and C equal? B could be equal to 0, and C would equal 3. If B equaled 2, C would equal 4. If B equaled 4, C would equal 5. And I'm starting to find a pattern here. What's that pattern? There is a special connection between the values of A and D and the connection between B. Whenever A and D is an even number, B also needs to equal an even number. I'm sorry, this should not work. Anyways, see, this is why whenever it's so important to find patterns, because then you can go back using this pattern and check if all of these are actually valid. You could have made a unnecessary mistake somewhere. Anyways, the pattern is that whenever A and D is an even number, B is also an even number. And whenever A and D equal an odd number, B is also an odd number. So moving on, we have 7 and 7. If A and D were equal to 7, again using the pattern, we immediately know that the minimum value for B is 1, which means that C would be equal to 4. Another option would be if it were equal to 3, then C would be equal to 5. If it were equal to 5, the C would be equal to 6. So that is for 7s. Now what if it's an 8? Well, it could be 8048, or it could be 826. 58, 84, 8468, or 8678. As you can see, as the value of A and D move up, more and more options come. And the final one is for 9. So if A and D is equal to 9, since 9 is an odd number, the minimum value for B is also an odd number, which is 1. So we have 9,159, 9,369, 9,579, and 9,789. And this is the furthest we can go because 9 is the last digit on our list. Now all we have to do is count how many options we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, okay, so I just checked and I found that out that I was missing one. For the values in which A and D equal 4, another option is available, and that is 4,234. See, this is why going back and checking is so important, because you can often find a number that maybe you missed or maybe doesn't work. Now, checking and double checking, we find that our final answer would be 20 numbers. So our final answer for this last question is 20. Please tell me if you knew about Math Olympiad before or if this is the first time that you've heard of it. And also you can tell me in the comments down below whether you got a 1, 2, 3, 4, or 5 for your score. Also, I'm curious to find out what was your favorite question to solve on this contest. My personal favorite was 1E because I like those problems that really challenge my brain and I have to go back. And I didn't even get this right on the first try. See, there were 2 times that I went back and I realized that I made a mistake, and then that's when I had to fix it. So it's times like these when we really improve our thinking and we really learn from our past mistakes. Again, I really had fun sharing my solutions with you guys today, and I'll see you next time.